All right, let's talk EC2. But we're going way beyond just clicking the launch button. We're diving into the stuff that really matters for building solid apps in the cloud. Things like performance, networking, and where you actually place your instances. This is about architecting things the right way from the very start.
So, you did it. You clicked that big launch instance button, your server's spinning up. So, now what? Seriously. This is where the real work begins, the thinking that separates a test project from a system that can actually handle the real world. This is your guide for what comes next. So first up, let's get our heads around the fundamental choices you're making, because it's way more than just picking a server size.
Okay, here's the first big mental shift you gotta make. An EC2 instance isn't just a generic server in the sky. It's a specialized tool. Are you training an AI model? You're gonna need a GPU-optimized instance for sure. Running a giant in-memory database like Redis? Then you care about memory, a lot of it. This choice is literally the foundation for how well your app is gonna perform. Now let's talk about something most people totally overlook at first, the problem of place. Yeah, where you physically tell AWS to put your instances has a massive impact on whether you're building for speed or for survival.
So here's the question you have to ask yourself. Do you need your instances talking to each other with the absolute lowest latency possible? Or do you need to make darn sure they don't all fail at the exact same time? Because you can't always have both. And AWS gives you a really cool tool to control this called placement groups.
Look at this. It's all about trade-offs. For insane network speed, we're talking high-performance computing. You want a cluster group. It packs your instances as close together as possible. But what's the catch? If that one physical rack fails, your whole cluster could go down. Ouch. For your supercritical apps, you'd use a spread group. It does the exact opposite, making sure every instance is on different hardware. And for big distributed systems like Kafka or Cassandra, a partition group gives you a nice middle ground. It keeps groups of instances on separate racks, giving you a good balance of performance and safety. Okay, our instances are in the right spot. Awesome. But now, networking. How on earth does an instance that's buried deep inside a private, secure subnet get out to the internet to download, say, critical security patches? The answer is a NAT gateway. You can think of it like a secure one-way door. Your private instances can go out to the internet whenever they need to, but the internet cannot, under any circumstances, start a conversation and come in. It is absolutely fundamental for secure network design. But you've got a choice to make. You can use the managed AWS NAT gateway, which is awesome. It's highly available, it scales automatically. It's the set it and forget it option. Or you could build your own on a cheap little EC2 instance. That DIY approach can be cheaper for really low traffic, but now you're on the hook for patching it, for scaling it, for everything. So, do you want to pay for convenience or save a few bucks and manage it yourself? That's the question. Now, for any serious production-level app, you never, ever rely on just one NAT gateway. That's a classic single point of failure. The right way to do it is to put a NAT gateway in each availability zone you're using. Then you just tell the instances in each AZ to use their local gateway. That way, if one AZ has a problem, your other instances aren't cut off from the internet. Simple, but crucial. All right, our instances are placed correctly, and they can talk to the internet securely. Now, let's give them a stable identity. Let's talk about IP addresses in EC2, because getting this wrong can cause some serious headaches down the road. So every instance gets a private IP. This is for all the internal chatter inside your network. It's stable, it doesn't change. Great. Now some instances also get a public IP, but here's the trap. That public address will change every single time you stop and restart that server. It's temporary, it's unreliable, and you just can't count on it. Let this one sink in, because it's a pro tip that will save you a world of pain. If you point a customer's API or a DNS record to one of those default public IPs, it's not a matter of if it will break, but when. The second you restart that server, poof, it's broken. So what's the solution? The solution is the Elastic IP, or EIP. This is a static public IP that belongs to your account, not to one specific server. You can attach it to an instance, and if that instance goes down, you just detach the EIP and slap it onto a new, healthy one in seconds. Your users never even notice anything happened. It's your permanent address on the internet. But, and this is a huge but, you have to remember this one thing about elastic IPs. They are free only when they're attached to a running instance. If you have an EIP just sitting in your account doing nothing, or it's attached to a stopped instance, AWS will start charging you for it. So please clean up your unused EIPs. And for all you power users out there, it's good to know what makes this all possible. It's something called an Elastic Network Interface, or ENI. Just think of it like a virtual network card. It's the thing that holds the IP address, and you can actually detach it from one instance and reattach it to another. This is the key to a lot of really advanced high availability tricks. Phew, okay, we've covered a ton of ground here, from where to place instances, to networking, to IP addresses. Let's boil this all down into a quick blueprint you can take with you. So here's the game plan. First, decide, speed or safety. Pick your placement group. Next, make sure your private instances can get out to the internet securely with a NAT gateway. Then, give your app a stable front door with an elastic IP. And please, please remember to release any EIPs you aren't using so you don't get a surprise on your bill. It's that simple. So now your architecture is solid. Your instances are placed perfectly, they're networked securely, and they have stable addresses. But what happens when the traffic starts rolling in? How do you distribute all those requests intelligently across your beautifully designed fleet? Well, that sounds like a job for a load balancer. We'll get into that next time.